Appreciate it. So what I want to do is go through a lot of people in the room that probably has not been in a tie plant. And Dr. Irby with RTA asked me to come do a general life cycle of ties. If you have done this, the same basic presentation we did at AREMA, some virtual something that everybody, I don't know. There was a lot of virtual stuff over the last several years. So, but if you got any questions or anything, I'll be happy to answer them. I'm gonna go through it fairly quick because Ryan's stuff is what everybody actually wants to see. But do want to go through a little bit of stuff on the ties. So this is something that RTA puts out. You can get it from them. It talks about all the different phases of the ties, all the way from logging up through the final use. So all of it starts in the woods. This is where my background lies. Is growing up in an area where logging was a big part of it. I was in and out of the log woods my whole life. So if you cut good timber, you grow good timber, you cut good timber, you manage it and take care of it, you're gonna get a better product out on the far end. And that goes all the way through. There's a lot of management that goes into that. There's a lot of continuing education that are required. In Kentucky, you have to have a master logger's license. There's a whole program that goes through that. It's continuous education that goes on, and there has to be a master logger on every work site if it's active. So there's a lot of good things that are going on. I've talked to several people this week. You can look up on the U.S. Forest Service. We have bigger and better timber than we've ever had in the United States right now. And if you don't believe me, which I would assume you probably don't, which is fine, go look on their website and find it. That's why I don't post any of their data on here, because I actually want somebody to go look for it. So all of it starts, we're sorting ties by species, we're sorting them by sizes and dimensions, lengths, all of this going into the sawmills. There's multiple different kinds of sawmills that cut them. They cut them up and send them into the treating plants, whatever company that is going to be treating them. These are a few of the products that we do, the bigger products that we do. Every tie has a home. This is a big deal. When a tie comes in, we want to find the proper place for it, whether it's going on a Class 1 railroad, if it's going on a short line, or if it's a construction job going into a siding somewhere. Every tie that comes in, our responsibility is to make sure we didn't waste it. It gets to the right spot. So we do that by grading the ties as we go through. All of that, what you order is based on what the railroad actually specifies, or what zones you're in. You may have different things going on there with different types of treatments. Jeff talked about borate. That became very popular in the South first for good reasons, because you have a lot more rot going on. This map is out of the AWPA manual. So if you want to consult it, there's a lot of good information in the AWPA manual. So this is in one of our tie plants. This is, I don't remember, Fulton maybe, but these are sorting bays. So we're coming in and our inspectors are looking at all these. They're flipping them. They're looking at all four sides and both ends. They're verifying the grade. They're looking for the species. They're looking for the size, and they're finding the best place to put that through. This is a couple videos that we don't need to see. That goes through an end trimmer to be trimmed to exactly 8.6 or 9 foot. On the cross ties, depending on what road's buying them. This is coming in, goes across there, and the inspector is sitting right here. So he's looking at those ties. They're actually being flipped over right in front of him, and it cannot go beyond that until he makes the grade. These are incisors. They're just teeth going in. I'll talk about these like expansion joints in concrete. It's made so that when the tie, as it's drying and water's trying to get out, instead of the wood splitting completely apart, we hope that the check, it's not actually a split, but the check goes from one incising tooth to the other and stops instead of going all the way down the full length of the timber. So this is something that we do. And then branding, everybody has different brandings, and this allows us to go back years later and figure out where the tie was produced, who treated it, and roughly the year that it was either stacked or treated. Then most of our facilities are robotically stacking ties now. That used to be a spot where we got a lot of people injured, so we invested in robotic stackers that do all of that work. Then they're put in air stacks, and they, depending on where you're at in the country, they're air dried for 6 to 12, sometimes 14 months. This is a process that works pretty good. A lot of the railroads really enjoy it. It's easier on the wood than Boltonizing. Boltonizing is a good way to dry them. This just does it more evenly and is not as hard on the wood up front. There is a lot of stuff that has happened since this timber was treated. We are no longer allowed to have bolt-on doors. They all have to be mechanical doors. We've got all the borates that have added in, and there's multiple different chemicals that we're using to treat now. There's some borings. This comes out of AWPA, verifying that the penetration on the borings were good. The picture on the top is the red, shows that these were 2-step borate dipped and then treated with creosote on top of it. And the ones on the bottom are pine and shows good penetration down through the growth rings. All of it has charts and graphs that go with it, so all of it can be verified by the end user. And then this is just new creosote and copper nap treated ties beside each other, and the far picture down there is some pre-plated ties that were pre-plated in the plant to go out. After all of that is done, the ties get taken out. They're delivered. There's several delivery systems and methods that are used to lay them out. Some roads do it on their own. Some roads hire outside folks to do it. One of the things that LTI does is they have a train that does this. He'll talk about that in a little bit, but lays the ties out. The old ties are removed, spikes are pulled, the ties are pulled out, the new ties put in, and then it's all gathered back up. So I'm going to turn it over to the fun part of the presentation.
Can you hear me? Yep. All right, appreciate that, Brad. So Aurora, so replacement ties. That's really what we're after. The industry, if you're not familiar with it, replacement ties is ties that aren't necessarily defective. Railroads don't wait until they get a certain population, say 25% of their track that has defective ties. If they waited that long, they get slow orders, that type of thing. So I say that because it seems really easy. If everyone in this room went out and walked a mile, we could all find the defective ties. It'd be really easy. We'd all find the good ties. It's all those ties in the middle that are questionable. It's the borderline ties. And so what makes up a replacement tie is a lot of different factors. And that's kind of what we'll get into today. But obviously, in the past 150 years or so, the conventional method was walking inspectors that would go out and either walk ties, counting, or painting. In the last couple of decades, they've had some supplemental tools. We've got a Husky unit, I think, up here, and an app on the phone. So these help inspectors grade ties and record their grades, but they still rely on a human to provide the grade. And I'll talk a little bit more about the subjectivity of humans. All right, so here's Aurora. Here's one of our trucks. Have you seen our data? That picture probably looks familiar. So we do a 3D machine vision scan of the track. We also have backscatter X-ray. You can see here, conventional X-ray has a detector on the back side of the object, which absorbs the X-rays. Obviously, we can't get underneath the tie, so we use a backscatter system that comes back and tells us the internal density of the ties. And it's really hard to see here, but yeah, it's terrible. So this is a point cloud. It's really zoomed in. Obviously, the projector is playing with us here, but if you could see each one of these pixels in a higher resolution, each one is defined in space and X, Y, and Z axes. We can define, we can measure plate cut, how wide a split is, how long a split is, if there's adzing, if there's warpage, height, spike height, all the attributes and variables of a tie, we can measure those. So this is some of the exercises we do. We're going to talk about grading models. So everybody can do this. All the technologies you've seen this week or last couple of days, everyone can measure data and produce these point clouds. But the real answer to tie grading is in the modeling. And so these are pictures that we go out with our customers and we walk track and we basically try to build a statistical model that replicates what their inspectors would grade ties. Okay. And so this is a little bit of hierarchy here of a typical railroad. On the left over here, we have, say John Check, the VP of engineering. As we come down the hierarchy, we have the roadmaster or the local track inspector. And typically what we see is if they're all looking at this tie up here, each one of them is going to grade it a little bit harsher as they get closer to the track, I like to say. The gentleman on the left has the 30,000 foot view of ties, right? So he's worried about the whole network. This gentleman over here is worried about milepost 1 to 150. And so typically looking at this same tie, they all differ on what they think the grade is. We typically in the past, we would build models with this individual in the hierarchy. And this individual might say, this is a 2.3 grade of tie. So we would model from 1 to 4, all these different tie grades. Well, then that person would ask everyone, is Aurora accurate? Does Aurora work? Well, depending on who you ask, we tell you no. It's not that Aurora wasn't accurate. It's that within their own organization, oftentimes there's no uniformity on tie grades. And so that's something that we had to learn to overcome in the past. We've been doing this for 10 years or so, is getting a model buy-in from the whole organization. Everybody from the VP to the local guy needs to all understand what is a 2.3, what is a 2.0. And without that, none of these technologies you see will be successful. Up here, I've got this tie. Everyone can probably agree. It's probably a 2.0 based on the splits and everything you see there. Another tie here, probably closer to a 2.0. Everyone would agree that tie looks worse. The reality is, this is the same tie. I took the picture with the sun in my back and the sun in my face, and just the light just plays with it. It really shows you the subjectivity in tie grading. All right, this is one of the inspector studies we've done. We've done these with UP and with BNSF, with NS. We really want to know, what is the human subjectivity when they walk ties? And so we do these exercises. We go out and we measure each inspector against himself and against his counterpart. And so you can see how often they agree on ties. If we look at Castle versus Sam, we can see in the increasing direction, they agreed 53% of the time. So half the ties that they're saying, I'll take this one, or I'll call this one a 1, this one a 2, this one a 3, or 4, they're changing that half the time. And so what happens when Roger and Sam, one inspects a job and one marks a job? They agree 29% of the time. You allocate 800 ties for this job, and Sam gets over there and says, you only need 600, or maybe you need 1,100. So what do you do? So there's a lot of subjectivity in grading, and that's where a system like Aurora or any machine vision system can really help you. First things we do when we get the data, it's easy to identify the rail tops, identify the plates, spikes, anchors. We isolate the tie from the ballast. We align the X-ray, and eventually we come up with a score here. Some customers it's 1 to 4.0, some customers it's 1 to 5.0. This is a statistical estimate of the confidence of the score. So if we're looking at a 2.5, we're basically saying we're 50% confident that tie is a 2, we're 50% confident that tie is a 3. So all the way up, and that's eventually what we're trying to get to. A little bit more detail here. You got the surface scores. We combine the surface score and the internal score. We can match the railroad's particular interest. Some railroads like a threshold for X-ray for the internal. Some like a weighted average between the surface and the internal. Some like just like the max. And so we can fine tune these models for every customer. Same thing with internal. You can see the return signature at the top is brightest. As we come down, we start to see an internal split. On the third tie, it's more severe. On the fourth tie, and this fifth tie is pretty much blown out. So we first started doing these X-ray inspections a few years ago. We didn't really understand what the heck does that split up there really mean. So we went out and we chainsawed ties open. We pulled them out of track. And we correlated what we're seeing in our data with what you actually see in the tie. And so that's how we have confidence when we grade an internal tie 4 or 2 or whatever it is. We know what how we're grading it. It's a customer that we did an audit with. We found this pocket of ties that was all internal. These kinds of conditions exist out there. When you drill these ties, this is what it looks like. Most inspectors wouldn't catch it. You walk over the tie, it's probably got a good inch of wood. Doesn't really sound hollow, but when you drill through it, it's pretty much like a drum, a cavity in there. It's full of mud and moisture. So check hit on this earlier. Winter ties replaced. We've got this idea that this life cycle of ties is pretty uniform. you know, it's predictable, you should say. But in reality, what we find is that this line is pushed and pulled depending on decay zone and tonnage and curvature and all these different metrics. And so it's very important to do your inspections and obviously assess your ties regularly. All the things that go into a replacement tie, again, not necessarily a defective tie, curvature, tonnage, tie cycle. When are we coming back? This one's huge. We could all look at one of these ties that we saw earlier. We could all say, yeah, it'll last another year, but will it last 2? Will it last 3? Will it last 4? And that really determines whether or not you need to pull it. Decay zone, neighbors is a huge one. The surrounding support for each tie it's dependent on its neighbors. Tie gang considerations. How many tie teams are you running? How many gangs are you running? Sometimes railroads will actually fluctuate what level of ties they pull based on the teams. Budgets, 3s and 4s, and the majority percentages. So I put that again, the 5s, the worst. The failed ties is the minority. When you go out there and see the ties that are stacked up, that are pulled out, it's not shovel outs, what we would call. These are still ties that were still technically functioning while they were in track, but they were at that point where they needed to be replaced before the next tie cycle came through. Risk factor, another one. So back to human grading, something we found that's just kind of interesting is that it's relative. When humans are walking, they're typically looking at 5 or 6 ties in front of them. And so they've got this threshold in their head that I'm going to take any tie that, let's say it's a 3.0 or above. And as they walk and they're not finding a tie that meets that threshold, they start to drop that threshold in their mind because they know I've walked 5 ties, I need to mark one. And so eventually they'll mark one, but it's down there at a 2.6 or a 2.7. And they kind of reset themselves and come back up. And now they're back at a 3. But since they just marked that one, they're usually a bit more lenient on their tie. So they keep walking and then they mark another one. And we see this ramping, and that's the matrix I showed you earlier with the variability between the inspectors. That's wise, because when you turn them back different directions, even amongst themselves, they're changing which ties they're taking based on the surrounding ties. And this is the last one here. This is a pilot that we did with a customer, just showing tie life with a tangent, a moderate curve, and a severe curve. So all this data that we're driving to, like Chick said earlier, we're trying to get to a tie life. If you know your tie life, that helps you predict and plan where you need to do your work, your budgets, a lot of different things. And so that's really the long-term answer with all this data is, what is my tie life? Okay, that's it, Brad.
So there's a lot of steps that it takes to get to that point where they're inserted in the track, and that's why that technology is helping a whole lot to keep the good ties in the track. If you're pulling it out too early, you're creating an issue when you could have left it in. It's a whole lot of wasted time and effort on doing all that. So once we get to that point, the ties are removed, they're stacked up and they're gone through. They sort out some roads will use relays, some roads will not. Any landscape timbers that can be used or salvaged to sell at the local farm stores are usually sorted out, high graded out, and whatever's left goes into fuel ties where they're being burned and electricity put on the grid. So that kind of closes the loop on the whole thing. There's a lot of moving pieces to get it through that process, but that is the process. So we'll take any questions and mostly Ryan will answer them.
I have a couple really basic questions. When you grade a log, what impact does the tightness of the green?
It can have some in some species. So in pine in the South, if it's plantation pine, it's grown in rows, it's a crop, it's grown like corn. Generally your density, your growth rings are going to be wider, they're going to be more uniform. And so you have a lower density overall on that product. But if it's natural grown pine where it's had to fight to get up in the top of the canopy to get sunlight, typically your growth rings are not as large. And so you get much more dense wood out of that. On oak and mixed hardwood, it's the same kind of thing, but generally that doesn't play in because the density is high enough on the species that we allow that there's no effect. Yep.
Showed when they were cutting the ends of the leg. How much allowance for the screen?
So most of the specs allow the shrinking this way that doesn't really occur, but the other dimensions it does. Most of them will allow a quarter or a half inch of shrinkage on a dry tie. So we're looking for a 7x9. It can be a half inch under on both dimensions, and the length generally doesn't change a whole lot. So we're cutting them exactly whatever length that they're supposed to be.
Any other questions? Thank you.